Okay, at the top corner of your page, go ahead and sketch your sine x and cosine x graph. Now, and for today's sketch, I want you to increase your resolution, putting a little bit more clarity into this sketch. Could you also indicate the period and also the y-axis values? Okay. So when you sketch your sine x graph and cosine x graph, try to indicate your x values and y values. Okay. So, as I said, it's very important, extremely important that you know how to sketch these two graphs at any time of the day. I hope for the rest of your life. So for sine graph, it goes from the origin, the middle point, goes up and down, and it ends at what x value? It ends at 2 pi, correct? And the highest point it can hit, it's 1. Let me put 2 pi over here first. The highest point you can hit, it's 1, and the lowest point you can hit is -1. And for cosine x, it starts at one. So it goes down and goes up, and it finishes the graph at x equals to 2 pi, and the lowest point you can hit to, it's -1. So that's the kind of resolution I want you to have for your quick sketch. Okay, so now at the top of the paper, you can see the equation that I asked you to write down yesterday. The A, B, C, D values. You can see that yesterday, and I would talk about the A value. What does the A value indicate? Vertical stretch, or related to the sine and cosine graphs? Amplitude, right? What about the D value? That's the vertical shift, up and down. C is left and right. So, and yesterday I said that, all right, the period is still 2 pi, the B value it's 1, and tomorrow it's going to change, which is today. So now, we're going to change that. But before we go anything into this part, I want to show you something. All right, I want to teach you how to be smart. But first, I'm not sure if you can see it. It's kind of hard to see if it's sitting far away. Can you tell the period? It's kind of small if it's if you're sitting at the very back. Can you see this 2 pi? And you have to have perfect vision to see it. So that's 2 pi. All right. Now, what if I show you only this much? Okay, if I only show you this much of the graph, can you still tell the period? How? Say again? It's a half the cycle, right? So the logic behind this picture is that, wait, hold on. You don't show me the whole picture. But wait, you showed me the half of the picture. So if half of the wave, it's pi, then the whole wave is 2 pi. All right, so this is just something I want you to be smarter. All right, so you don't really need to see the whole wave to tell the wavelength. If you see half of the wave, still good. Okay? All right. Now, what I want to do is this. So I want you to see the whole wave right here. So from 0 to 2 pi. And what I'm about to do is to type in one more equation. So if I put in sine of 2x, all right, can you tell the period for sine of 2x? It's pi, right? So from here to here, this is pi. So the period, it's going to be pi. This one was 2 pi. Okay. Now, what if I show you another equation, which is y is equal to sine of 4x. Ooh, that's kind of messy. Let me take away the blue one. Pi over 2. So my question is this. Given that the value sitting in front of x is the b value, how is the period interacting with the b value? Are they multiplying or are they dividing? They're dividing, right? So that's why we say period, it's equal to 2 pi over b, which is printed on your paper already. Okay. Now, let's do some rearrangement of terms. If period it's equal to 2 pi over b, so b it's equal to, say again? B is equal to 2 pi over the period. Now, this is the part that I'm worried the most. Because I think that some students will make some mental mistakes when they rearrange the terms, especially the people who are taking the SAT this weekend. Anybody? SAT this weekend? 1, 2, 3. Okay. Wish you good luck. So now, how can you make sure that you do not mess up when you rearrange the terms? Just do whatever you learned back in Algebra 1 in middle school. Just do the same thing on both sides. You want to get b by itself? Multiply b by both sides. Okay. So I multiply b on both sides, and then you divide the period. So that's how you get b equals to 2 pi over the period. It will come in handy in a short moment. Okay. So we have gone through all the A, B, C, D terms by now. So let's go ahead and have some fun with these graphs with our A, B, C, D terms. Okay, so now let's look at the first one. What's the amplitude? W1. Vertical shift. Down 2. Horizontal shift or phase shift? Nothing, 0. Okay. So what's the period? So your eye, your vision will zoom into the value sitting in front of x. That it's 1/2. So what is the period? Because period is 2 pi over b. So now let me zoom in. So period, it's 2 pi over b. In this case, it is 2 pi over 1/2. Now, again, I have some worry. I have some worries right here that some of you may not know how to deal with this kind of complex fraction. So in case you are one of those students, let me just remind you that your middle school math is actually very useful. Don't leave them behind. 2 pi over 1/2, that means 2 pi it's divided by 1/2. That means, well, what you learned in middle school about dividing a fraction. Multiply by the reciprocal, right? That's why it's equal to 4 pi. Now, another way to think about this is, wait, hold on, 2 divided by 0.5. 2 divided by 0.5. How many times does 0.5 go into 2? 4 times. So, a lot of ways to think about simple math. Okay, so our period is 4 pi. All right, what's our range? Well, our original range for sine graph, it's from -1 to 1, +1. And then it's being shifted down 2 units. So that means we are going to have a new range of -2, comma 0, right? -1 to 1, and then you move down 2 units. Wait, hold on. No, -3, -3. So yeah, -3, comma -1. Yeah. So -1 to 1. So yeah, down 2 units. And down 1 unit will be -2 to 0, but down 2 units will be -3 to -1. So where should we put our initial point? 0, comma -2. We start in the middle. It's a sine function, right? And where do we put our next point? Say again? That's hard. The next point is 4 pi. Because after one period, it goes back to the same point again, right? Like I said, you've got to know your sketch. Sine graph goes up and down and up. So that means in between these 2 points, we should have a point where 2 pi comma -2. Because again, sine graph goes up, down, and up. If you don't know your sketch by heart, it's just hard to convince yourself. And the fourth point that we put would be at pi comma -1, the highest point. And the next point, our final point for the first wave, 3 pi comma -3. Woo. Okay, so that would be our first graph. So what you see here, it's every 4 squares, you can expect to see a major point. So if I would need to work my way backward, I would say, all right, go back 4 squares. I should have a point at -3. Furthermore, to the left, back to -2. Done. Let me change this. Let me change the color so they can see the green is the green color is my first wave. Okay, that's the first point at 0 comma -2. That's the first point. Okay, finish the first wave, and then I can finish the remaining part. So in this case, we have the B value and a D value. Okay. Right now, I'm going to give you 1 minute to fill out the blanks for part B. You've got an A value sitting in the front, you've got a B value sitting in front of X. So go ahead. Go ahead. So for part B, what's the amplitude? 3. Oops, no, it's fine. Vertical shift, 0. Phase shift, 0, none. Okay. Period, pi. The range is -3 to 3. So where do we put our first point? It's a cosine graph. 0, 3, 0, comma 3. And where do we put the next point? Pi, comma 3. Because the period is pi. So that means after pi units, it goes back to the highest point. So in between the two highest points, we must have the lowest point. So at pi over 2, it hits the lowest point. In between the highest point and the lowest point, it must hit the middle point, the midline. So what you can see is that you are going to draw a lot of waves for this one. You got to do a lot of replications. Okay. So let's take some time to do some replications. But now, how can you not drive yourself crazy when you do these kind of graphs? You have to utilize the idea of pattern and symmetry. So now this is how I would work my way out. I'll be like, wait, hold on. Can you see that every 4 squares, it's going to hit the top part again? Let's do that. Every 4 squares, 1, 2, 3, 4, highest point. 1, 2, 3, 4, highest point. 1, 2, 3, 4, highest point. Okay, let me do the part on the left as well. 1, 2, 3, 4, highest point. 1, 2, 3, 4, highest point. The same thing for the lowest point. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Got all the lowest point plotted here. And then what about the midpoint? You can see that it's every 2 squares. So we're going to make a lot of waves right here. Now, this time, I think it's also a good time for me to make sure that what I am expecting from your graph, I expect that you will make a deliberate attempt to draw the dots. Like, I can accept your line not being perfect, but I cannot accept that your dots not being there or not being at the accurate place. I cannot accept that a graph is not symmetrical. In the roughest sense, okay? I'm not saying that everyone needs to be an artist, but at least you have to show some deliberate effort to make it work. Okay? Cool? Yes.
Is it necessary to draw like even like the negative, or you have to draw the whole thing from negative?
Oh, that's a good question. Now, do you have to draw the whole thing? Well, you are given the graphing area, then I would say you do need to fill out the whole graphing area. Okay, you have plenty of time, and probably won't belabor you for the whole quiz or test. But yeah, if we give you the whole graphing area, then you need to draw the whole graphing area. Okay. All right, now let's go ahead and look at part C. Ooh, part C is like a medley. We have all the A, B, C, D values all shown in here. So go ahead, take a minute to write down all these important values. What do they represent? Okay, what do they represent? So let's go ahead. How does it affect the amplitude, period, vertical shift, horizontal shift? You have the A, B, C, D values. All right, so you have the A value there. This is your A, this is your B, this is your C, this is your D. What's the C value here? Technically, it should be negative pi over 2. Okay. So our amplitude is 2. Our period is 4 pi, just like the first question. Phase shift is left pi over 2. The phase shift does not affect the period. Vertical shift down 1. So the range, well, so originally it's -1 to 1, but there's a 2 sitting in front of it. Okay, so so the amplitude's changed to 2, so that means our new range is going to be from -2 to 2. And then we move down 1, so it becomes from -3 to 1. So where should we put the first point? So now originally I would put my first point right around here. That's my first point originally. No, originally is here, but because of the stretch, it goes up to goes up to 2, and then we have to move to the left for pi over 2 units, and then it's being shifted down 1 unit. So we will settle our first point right here at negative pi over 2, comma, wait, hold on, comma 1. Yeah. That's where we settle our point. Okay. Again, originally it's 1. Because of the amplitude, we will, well, we shift to the left, and then we have to change the amplitude, which is going to be 2. but then we have to move down 1 unit, so it comes back to y value of 1. So that's the first point. What's the next point? Not 4 pi comma 1. 7 pi over 2 comma 1. Because it is 4 pi units away to the right. Okay, yes. This one? If there's no minus 1, then it will be 2. But because we shifted down 1, that's why our range is from -3 to 1. All right, so it's a cosine graph. So the 2 dots presented here, they are the highest points. So that means somewhere in the middle, it must be the lowest point. So right in the middle, at 3 pi over 2, that's where we will see our lowest point. And in between the highest point, and the lowest point, we see the graph hitting our midline right here. So make sure it's symmetrical, make sure all the major points are equal distance away from each other. So it seems like we have a major point every 4 squares away from each other. So that's our first wave. And then you have to work your way out for the remaining parts of the graph. So again, we see that every 4 squares, we have a major point. So 1, 2, 3, 4. We'll put a point right here. Okay, it's going to hit the mid line again. And 4 more squares to the left, it hits the bottom. And then 4 more squares to the right on the right end of the graph. It should hit the middle. So I'm okay with you if you exceed the graphing area, but you never go short of the graphing area. Are we good? Okay. Which part? Uh-huh. It starts at 0, 1, yes.
And then go up to the amplitude. So
Yeah.
3.
No. 2 times 2. 1 times 2, it's 2.
Oh,
Yeah. Yeah, the amplitude it's 2, so that means that goes from 2 to -2. All right, so now, we now know how to graph all these stuff, and the final piece of this week's material, the final piece of this semester's material, actually, this is the final piece of the semester material. Semester. Can you believe we are at the end of the semester? 3 months. 3 months? No, 4 months since August. Okay, so now, so we are now giving you the graph, and we say, hey guys, can you now give us the equation? So if you look at this, we'll say, well, what can you tell straight away? It's a sine function, right? So we'll say, yeah, it looks like a sine function to me, because it starts from the middle, right? So it looks like a sine function. What else can you tell? Amplitude of 3. That means your A is 3. Is there any shift? Nope, no vertical shift, no horizontal shift, no phase shift. That's good. What's the period? 4 pi. The period's 4 pi. Yeah, so the b is 1/2. So this is so if you use the earlier part, I told you the equation, b is equal to 2 pi over the period. So can insert the period right here. So pi cancels out, 2 over 4, it's 1/2. So b it's 1/2. So 1/2 x. Done. So you become very sensitive to all these values. Now, in terms of applications, I would say these sine and cosine graphs, these sinusoidal functions, they are really, really good because we can use it to model a lot of things. I think about how you can model the morning traffic outside of school, like right before 7:25, it's like it goes up, and then right after 7:30, it drops. Always causes people headache. All right, now, are we good so far? You can extract all these values. So now I'm going to throw you a curveball. I want you to catch the curveball right here. So what if I ask you this? I would say, hey guys, y equals to cosine function. Okay, y equals to a cosine function. And you're like, wait, cosine function? Can we write this as a cosine function? You can think about it as a reflection, or you can simply think about that as a shift to the right, right? So we start at the highest point, and where's the highest point right now? At pi. So the features that will remain the same is that the period is still 4 pi, so the b value is still 1/2. The amplitude is 3, that stays the same, but now it's being shifted to the right for pi units. So this can also be represented as a cosine function. They are both valid. And technically speaking, we have infinite amount of possible equations for these guys. Okay, we can say, hey, can we say it's like a negative cosine function that starts right here at 3 pi? Sure. Okay, sure. So, but of course, for now, we are always going to go with the simplest way. Okay, if you see that it starts from the middle, you think that's a cosine, it's a sine function. So for part B, it starts at the highest point. So you think about, yes. No, the period stays the same. Like I start here, but if you continue to graph it, it's still 4 pi. It won't change. So for B, would you use sine or cosine function? You would say cosine is better. All right, so what kind of information can we extract from the graph right here? Shift to the left for pi over 4. That means we will write down x plus pi over 4. Can you tell the amplitude? 2. Any kind of shift, vertical shift? Down 1. Okay. So now it may be helpful for you to just quickly sketch the midline. That tells you the d value. The d value, it's shifted down 1. Any, what's the period? The period is from negative pi over 4 to 3 pi over 4. Period is pi. So therefore, the b value is 2 pi divided by pi, which is 2. So you would place the b value right here, but you would have to make sure that you put a pair of parentheses around the x plus pi over 4. Okay? All right, so yeah, so for the period, now for the period, how can you get the period more accurately? Well, the distance, right? The distance from the peaks, between the peaks. That's what you do. So that it's 3 pi over 4 plus pi over 4, and that is 4 pi over 4. Okay, so that's a full pi. That's the equation. Question? All right, I'm going to let you try part C on your own. Give you 2 minutes. Pretty straightforward, except that the x-axis looks a little bit normal in this case. So go ahead, extract all those critical information, such as period, amplitude, and see how it affects your finding on the finding of the A, B, C, D values. So what's the amplitude here? The amplitude is amplitude. That's a midline. What's the distance from pi to 4 pi? 3 pi. Not 3, but 3 pi. Okay. What's the period? 6. Any shift? To the right by 1 and vertically. So that means our what function are we going to use? Sine or cosine? Sine, because we start in the middle. So the b value is, ooh, what's the b value? B is equal to 2 pi over 6. B is pi over 3. Our amplitude is 3 pi, so A value is 3 pi. We shifted to the right by 1 unit, so x minus 1. And then up pi, so that's our equation. Now, I personally like this equation, like this picture, because it kind of breaks a little bit of your presumption. You might be thinking that b value is always a nice number. Well, I'm going to tell you that b is a number. It could be a number by itself. It could be a number with a pi. It could be anything. It's just a number. B is just a number. A is just a number. It could be a number, a clean number like 1, 2, 3, and 4. And it could also be a number that is with a pi right there. It doesn't really matter as long as it is a number. Okay. So do not let the appearance of pi freak you out. Please don't. Okay. Pi is just a number that we use. Okay. All right, now that's pretty much it. Okay, that's pretty much it for the week. Tomorrow, when you come in, we'll do a bit more practices. This morning, I set up a delta math exercise that you can use to play, to practice. I can test out the, try out how the all the ways to write down the equations. So tomorrow, again, you come in, you practice. We see more things tomorrow. Friday, we have the quiz. Monday, Tuesday, we will review. And then Wednesday, we have a quiz. Thursday, Friday, review for exam. Next Friday would also be, there will also be a unit circle quiz. Quiz based on unit circle. Okay. Yes. We will talk about it during lunch, so I will give you the answer tomorrow. I will give you the number of questions. I expect somewhere around 75-ish. Like, given that the exam is 2 hours long. The quiz will be about the graphing primarily. Don't forget the stuff we went over on Monday. All those supplementary, the complementary angle stuff. Sine theta is equal to cosine of 90 minus theta, even an odd function. Okay, so keep that in mind. Keep that in mind.